All right, let's graph some cotangent graphs. So as you can see, we have the cotangent, the typical one, just cotangent of x drawn out up here. What we want to do is just focus on one period of this. Typically, we go from 0 to pi. And remember that this is reciprocal of the tangent graph. So where the tangent's equal to 0, cotangent's going to get a vertical asymptote there. So both at 0 and at pi on this first period. And then we're also going to have where tangent has a vertical asymptote, cotangent's going to have a 0 or x-intercept at that same point. So as we get going on this, let's try a pretty easy one from the very beginning. And then we will move on to a much more difficult one in just a second here at the bottom. So as we get going on this, let's first of all focus on this number out in front. That's going to be a stretching factor. So what that tells us is we have labels on our y-axis at +3 and -3. And we're going to identify key points that have these as their y values in just a second. Now I jumped straight in here instead of doing side work because this doesn't have any horizontal shifts, no numbers added or subtracted directly to x. And it also doesn't have any vertical shifts, no numbers added or subtracted to the entire function. So pretty basic one going on here. The next thing I'm going to focus on is this 4 on the inside. We haven't accounted for that yet. So that's going to affect the period of our function. Now, normally the period of cotangent is just going to be pi. Just like with tangent, it also has a period of pi. But then to get the total period, what we want to do is that multiple on the inside there, the 4, we're going to take the original period and divide by that multiple from the inside. So what that tells us is that the entire period, the total distance traveled from beginning to end on this is just going to be pi over 4 as opposed to the original pi. All right, so this is going to start at 0 and it's going to end at pi over 4. Other things to note, being that this didn't get shifted, the y-axis is still going to be a vertical asymptote. And then this value we just came up with is going to be a second vertical asymptote. Other labels on our x-axis, we get 1 directly in the middle. So half of pi over 4 is going to be pi over 8. And then these other two values, what we want to do is be a little bit careful here that this value is going to be halfway in between 0 and pi over 8. So again, if you divide by 2, you can get pi over 16 as a nice label there. And then if you took the average of pi over 4 and pi over 8, you get this value in the middle. That turns out being 3 pi over 16. And we want to be a little bit careful with those values that to get a really good graph, you want to indicate these key points along the way. All right, so as I try to graph this, things didn't get flipped upside down. We don't have a vertical reflection on this, so it's going to be decreasing the entirety of this graph. Kind of put these key points in. What I'm trying to do is I'm trying to line this up so this key label on our x-axis goes along with this y value on the y-axis. Same thing, this key value that we labeled on the x-axis goes along with -3 on our y-axis. After we have those sketched in, just want to make a kind of nice looking graph connecting those dots. And when you get to the vertical asymptotes, you have to choose whether to go up or down. This one's decreasing the entirety of the graph. That's not a bad looking graph. All right, let's move on to the more difficult looking one here at the bottom. We have 4 times the cotangent of pi over 8 times x minus pi over 2, with a -2 being subtracted away from the entire function. So we have a few different components going on here. We have some vertical labels I'm going to work on the left-hand side. We have some horizontal x-axis labels I'm going to work on here in the middle. But before we get going on this, let's first go ahead and do just a little bit of factoring and rewrite this. So this is 4 multiplied by the cotangent. I'm going to factor out that pi over 8 on the inside here, and I think that's going to make life a little bit easier as far as visualizing what's going on with transformations. So it's pretty easy to see that we can take it away from the x, factor it out, just put it on the outside because pi over 8 times x gives us pi over 8 times x here. The more difficult part is this pi over 2 on the inside. So what I'm going to do initially is I'm simply going to put a c as kind of a placeholder here. And I want to visualize if I take pi over 8 and I multiply it by c, I need to get pi over 2. So a little bit of side work over on the left. I'm going to say pi over 8 multiplied by c has to equal pi over 2. So let's do a little work and solve down for c in this side equation. So what I need to do is isolate c. I'm going to need to both multiply by 8 and divide by pi to get rid of that from this side. So multiply by 8 on both sides and divide by pi. So we can reduce this down into multiply by the reciprocal of the fraction that was on this side, because that'll take care of everything kind of all in one shot. 8 over 8 makes 1, pi over pi makes 1. That'll give us c on this side all by itself. Then with a little reducing down on the right-hand side, we have a pi in the numerator, pi in the denominator. That creates a 1. But we still have 8 in the numerator divided by 2 in the denominator. So 8 over 2 works out to be 4. So what we can do is where we have that plus c on the inside here, I'm going to just real quickly replace that with a minus 4. And if we redistributed pi over 8 times 4, sure enough, is equivalent to pi over 2. Now, why I want to rewrite it like this by factoring out the common factor is it makes it a little easier to see what's going on here as far as what we have as a multiple and a horizontal shift. Let's go through that in a second. But first, let's pick out this 4 out in front. That contributes to y value labels, meaning that we have 4 and -4 are going to get labeled on our y-axis as key point values. And I'm also going to go ahead and label 0, kind of corresponding to this middle point as we're graphing this. All right, so that takes care of the 4. Done. The only other vertical movement we're going to have is this -2 attached to the entire function. What that's going to do is it's going to move everything down 2 units. So for each one of these labels that I already have on my y-axis, I'm going to subtract 2 from each one of those to get my new labels that are going to go on our final graph here. So in subtracting 2 from each of these, we have 4 minus 2 makes 2. 0 minus 2 makes -2. And -4 minus 2 makes a -6. Just being careful with our labels that are going to go along the y-axis. And I'll go ahead and put those on the y-axis. So we had +2, -2. I guess that'll be -4, which we don't get a point at, and -6. All right, again, -4 is not one of these key values that's over here. Neither is 0. Just went ahead and labeled it to try to keep everything nice and organized. Next, our x-axis. Let's first think about our period for this x-axis. Now, typically the period for cotangent is going to be pi. But then what we want to do is divide that by any multiple that we have on the inside here. So the original period for cotangent divided by this multiple. So we're going to go pi divided by pi over 8, which is equivalent to pi, copy down the numerator, and then multiply by the reciprocal. So I'm going to take the pi over 8, and I'm going to flip it upside down, use its reciprocal. That's going to be 8 over pi, which reduces down just to be 8. So what that tells us, the period being 8, that it's going to be 8 total units from beginning to end. And if I wanted to label my x-axis, that would be from 0 to 8. I want to point halfway in between, which will be 4. Halfway between that will be 2. And halfway between 4 and 8 makes 6. So that takes care of the initial labels, but then we also have this -4 attached directly to x. What that -4 is going to do is that is going to shift everything to the right 4 units. So what I'm going to do with my labels here is I want to add 4 to each one of these. All right, so 0 plus 4 makes 4 for my leftmost label. 8 plus 4 makes 12. And I can do the same thing for each one of these. They increment up in units of 2. So the middle label will be 4, we have 6, we have 10. All right, now that we've labeled all of the x-axis labels going on here, let's go ahead and put those over here on our x-axis as well. So I'm going to go ahead and say, well, 2, don't really care about that one, but just to keep it nice and organized, we have 4, 6, 8, 10, and 12. All right. At the initial label, what I got down here at 4, that's going to be a vertical asymptote. So just kind of sketching that in using a vertical dashed line. The last label we got, 12, is also going to be a vertical asymptote. One more vertical dashed line going on here for our graph. And then these other ones, what we want to be careful of is just like the original one, the cotangent, this is going to decrease the entirety of the graph. So it's going down as we move from left to right. These 3 inner labels, what they go with are these 3 labels on the left-hand side, like our vertical axis labels. So we're going to have an ordered pair at 6, 2. We're going to have an ordered pair at 8, -2. And we're going to have an ordered pair at 10, -6. So try to get those points lined up, -6 for a y value, 10 for an x value on that last one. From here, now that we have all of our key points already plotted, we've got our vertical asymptotes plotted, we've got our x-axis labeled, y-axis labeled. All that remains is to basically sketch this in, connect the dots, and make sure when you get to that vertical asymptote, we have to choose to either go up or go down, depending on which side we're on. So there we have it, a nice graph of this very complicated looking cotangent graph. And we've just graphed it for one period, but I hope this helps as we kind of walk through one step at a time on graphing this. So good luck, take your time, label, label, label.